Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding.
Well, a thin equi-convex lens of focal length f is sliced into two equal parts by a vertical plane AB. What is the focal length of each of the sliced part? So we can use the lens maker's formula to determine this. Using lens maker's formula, and it says 1 upon f is equal to mu 2 1 minus 1 upon r1 minus 1 upon r2. For biconvex is also known as equi-convex. So they both are the same thing. So for biconvex lens, R1 is equal to R and R2 it is equal to minus R. So I can write 1 upon F is equal to mu 2 1 minus 1 upon R minus of minus 1 upon R. And it becomes equal to 1 upon F is equal to mu 2 1 minus 2 times of R, 2 times divided by R. So F is equal to R upon 2 mu 2 1 minus 1. This is my equation number 1. Now when it has been sliced into two equal halves by a vertical plane, each of the half becomes a plano-convex. Now for plano-convex, R1 it is equal to R and R2 it becomes equal to infinity. So I can use these values in the lens maker's formula to determine the focal length of plano-convex. That is the sliced part. So 1 upon f dash, it becomes equal to mu 2 1 minus 1. No change in the refractive index, only the change in the radii of curvature for the respective spherical surfaces. So 1 upon r minus 1 upon minus infinity. So that becomes equal to mu 2 1 minus 1 divided by r. 1 upon infinity can be taken as 0. This is the value of 1 upon f dash. Now f dash, it becomes equal to r upon mu 2 1 minus 1. This is the value of f dash. Now if I can compare these two equations, I can clearly see this thing that f, it is equal to f dash by 2. This value that I'm encircling, it is the value of f dash. So I can write f is equal to f dash upon 2. And this implies f dash is equal to twice of f. So when we slice the convex lens by a vertical plane into two equal halves, each of the half will have a focal length that is twice that of the original equi-convex lens.
Keep learning, keep practicing, keep excelling.